Mhm. Finally, finished today's work, and I'm going to do some coding for fun. Let's see. Medium problem one from Google. Given the root of a binary tree, return the length of the longest consecutive path in the tree. This path can be either increasing or decreasing. For example, 1, 2, 3, 4, and 4, 3, 2, 1 are both considered valid, but the path 1, 2, 4, 3 is not. On the other hand, paths can be in the child-parent-child order, where not necessarily be parent-child order. Interesting. Consecutive path. Hmm. Okay. It doesn't matter, right? If we search from the smallest node, we are going to find the longest path we have, and that one must be also the longest path we can find from the biggest node, right? So how about we convert the binary tree into a graph, and we are going to do a deep first search on that graph on each of the nodes, and search for the longest increasing consecutive path for each starting point. Sounds good. So the complexity of that solution is, let's see. First, we need to have a graph, and that complexity is O n, right? And then we are going to iterate through each of the node as the starting point and traverse all the possible increasing paths. Okay, so let's get started. First, we're going to have a graph G, all right, or graph W. And how can we construct such a graph? Something is ambiguous, so is 1, 3, 4 a valid path? I know it says consecutive, but it doesn't explain what is consecutive. I mean, two adjacent node can also consider as a consecutive, right? Whatever. Let's try it. So this is the graph, and we are going to deep first search. So this is a graph, and we're going to traverse the root. DFS binary tree, right? The last node is now, and BT tree node, current node, tree node, last node, and create an edge between current node and the last node. So G last value insert. Wait. Are those numbers unique? The number of nodes in the tree is in the range. So it's not necessarily unique. Interesting. So we need to create a map here. Why it is a median problem, I don't understand. So last it, so we assign a index to the current P. Node count. Also need to store value somewhere. So if last is not equal to -1, that means we can create an edge here, which means G last index insert current index. And also likewise, current index has equal to last index. And we're going to do this to the child of B. Both left child and right child. Thus, we constructed the graph, right? Shall we do a little verification to make sure everything is alright? This is head. This is links. Right. Let's see. We constructed a correct graph. Right. Cool. 2 has 0 and 1. That is problematic. Okay. We need a new character here. So 2 has 0. Right. 1 has 0. 0 has 1 and 2. Yes, the graphic looks good. Then we're going to DFS all the nodes. This is starting point. And we are going to keep the longest path in the memory. What? Search from I. Current length is 1, and the current value is and going to record the longest one, right? And return the answer. So let's traverse, search all the paths and store it in the memory. This is the current node, and this is length, current length. This is the current value, and we're going to search from here. So then first we're going to update it. Then we're going to try all of its neighbors. And for each of the neighbor, we have to make sure that the neighbor's value is 1 bigger than v. We don't actually need to store the v here, right? That is not necessary. We just still need to access the value here. If they're equal, then we can calculate wait. That's funny. We don't need all this. Come on. It's just a memory search. Okay. Try the test cases. Looks good. Why it's so slow? Single traversal. Yeah, my approach is quite unnecessary for this one. Okay. Yeah, that actually makes sense. Just need one traversal. So he tries the decreasing order traversal for both of its child and try increasing path traversal for both of the childs. And this two child has the potential to combine a increasing and a decreasing traversal. And we just need to pick up the biggest, right? Yep. Yeah, that solution is much more simpler. So my approach is quite complicated and stupid. Sorry about that, but still we solved this problem, and I don't want to get into the trouble to implement that approach. So let's just head straight to the next medium problem. Design a algorithm to encode a list of strings to a string. The encoded string is then sent over the network and is decoded back to the original list of strings. Huh. What is a big deal? Just encode and decode a list of strings, right? Hmm. We can use a special character to concatenate all the strings, but that is risky because we don't actually know the strings we have. Hmm. So we need some head, need some kind of head, right? Okay, let's do this. we are going to put a length string in at the front, right? Let's do this. This is our length string, and each time we put in the length, and never mind it. String is we create the string directly. And what if the string itself is 1, 2. Okay. This is the noise array, and we use a pointer here. Well, sp is not equal to period. Going to do this. Well, sp is not equal to current pen is 0. Going to sp minus 0 p plus plus p plus 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 plus. So already down all the last reading there. I'm going to generate the string list. To generate the first string, just need to push it substring started from P, and the length is Li, and we need to increment P by the length. Then return this. Looks good. What is going on? Five. So I didn't read any number here. Oh, this is funny. Push back at each time. Cool, I guess that's it. Let's remove the output. That hatred. Okay, thank you for watching.